All right, so we're going to use that. Oh, this is the second trig identity that we're going to learn about in this lesson, and it's that tangent is equal to sine over cosine. That also holds true for tangent squared. Tangent squared theta is equal to sine squared theta over cosine squared theta. So let's see how that works. And we saw that actually back here when we did that tangent is y over x, because if we go back another one, here where we did tangent equals opposite over adjacent, what we're actually saying is the y value of this point is the opposite over the x value of this point, which is the adjacent, right? So opposite over adjacent is the same thing as saying the y value over the x value. And that's why we were able to do it here. And that's where this identity comes from. And then the relationship doesn't change when I square the trig functions. So let's keep that in mind, and let's take a look at, see if we can simplify this. We know that we can replace this with this, right? So I would have sine squared theta over cosine squared theta times. Now I'm going to take this trig function right here, and because I like to have a fraction times a fraction, I don't want to have a fraction and a non-fraction value, I'm going to make this into a fraction as well by putting it over 1 plus cosine squared theta. So you can probably see where I'm going with this, because since I have a cosine squared on the top and the bottom and I'm multiplying here, I can cancel those because they equal 1. So then I'm left with sine squared theta plus cosine squared theta. But we just looked at that in the previous example, and we know that one of our identities is that cosine squared theta plus sine squared theta equals 1. So this is actually going to simplify to 1. So we used both of the trig identities that we're practicing with in this lesson in this one example. All right, let's try another one. So 1 minus cosine squared theta. Now remember, we know that actually, let me do cosine first. We know that cosine squared theta plus sine squared theta equals 1. So this looks like I took the cosine and subtracted it from the 1, right? So I'm going to do that. Minus cosine squared theta minus cosine squared theta. And I'll get sine squared theta equals 1 minus cosine squared theta. Okay, and then if I'm solving for sine theta, I would have to square root both sides. And I get that sine theta equals the square root of 1 minus cosine squared theta. So we can replace this part with sine theta. So I'll get sine theta over cosine squared theta. Now, I could leave it like that if that's an option. If that's not an option, I could rewrite this as sine theta over cosine theta times 1 over cosine theta, right? Because all I did here was I took the cosine squared and I broke it up into cosine times cosine on the bottom. Then I can keep going because I know that sine over cosine is tangent. So I could write tan theta times 1 over cosine theta. And I could even simplify that a little bit more if I put this over 1. And I could write tan theta over cosine theta. Now, this is a perfectly acceptable answer, as is this. It just depends. If you were doing something that was like a multiple choice assessment, or, I mean, they're both completely simplified. So it would just be whatever form you need it in. If you need it in a form where it has tangent because you're given the value of tangent and you have to find something else, then you would want to go all the way to here. But if you're given, I don't know, maybe the sign and not anything else, then you might want to use this form. But these are both perfectly acceptable, completely simplified forms of the answer. All right, one more. So here we have what looks like two binomials, right? So I'm going to multiply them the same way I would multiply two binomials. I'm going to FOIL. So that means first, and then outer, and then inner, and then last. And my two middle terms will cancel out, which for those of you that are really good at factoring, you probably saw that from the get-go and probably didn't even do those two middle terms. So kudos to you. That's good if you picked up on that. So I get 1 minus tan squared theta. And that's all I can do. Again, you know, we know that tangent is equal to sine over cosine. So if I wanted to, I could rewrite this as 1 minus sine squared theta over cosine squared theta. But again, we've got the same situation as we saw in the last problem, that this is a perfectly acceptable, completely simplified answer, as is this.